Hi to everyone, myself Dr. Dhananjay Rao. Today I am going to discuss about Introduction to Single Electrode Potential and Electrochemical Series. In this session I am going to cover what is single electrode potential, what is standard electrode potential, what is electromotive force or cell potential, and some numerical calculations on cell potential, what is electrochemical series and applications of electrochemical series. All those things I am going to cover in this session. Single electrode potential. When a metal is placed in a solution of its own ions, the potential developed at the interface between electrolyte solution and metal is called single electrode potential. What is single electrode potential? When a metal is placed in a solution of its own ions, the potential developed at the interface between electrolyte solution and electrode is called single electrode potential. If we take one glass beaker, if this beaker is filled with electrolyte, let's say zinc sulfate solution. In this, I have dipped zinc rod. The potential developed the interface between this electrode surface and electrolyte is called single electrode potential. What is the origin of single electrode potential? How the single electrode potential develop in this electrochemical cell? When a metal rod M is placed in a solution of containing its own ions, zinc is dipped in zinc sulfate solution. If I take the metal atoms from the solid metal rod enters the solution as aqueous metal ions, the leaving n electrons on the metal rod. When I dip metal rod in electrolyte solution, the metal rod undergo oxidation, zinc undergo oxidation, forms zinc plus 2 ions and 2 electrons. These electrons are appeared on the zinc electrode. The excess of electrons are deposited on the zinc electrode. The M plus 2 ions or zinc plus 2 ions are going into the electrolyte solution. Okay. Likewise, at the same time, metal ions from the solution gains electrons from the solid metal rod and is deposited as a metal atom on the rod. This solution contain electrolyte solution contain zinc plus 2 ions. These zinc plus 2 ions undergo reduction by taking these electrons forms into zinc. This zinc is deposited on this zinc rod. Okay. Metal ions from the solution gains electrons from the solid metal rod and deposited as metal atoms on the rod. The metal rod acquires a negative charge since there is an excess of electrons around the metal. The electrode getting a negative charge because number of excess electrons are present on the zinc electrode. The solution surrounding this metal rod acquires a positive charge due to the excess of positive ions in it that creates a electric double layer. The electrolyte solution contains excess of zinc plus 2 ions. The electrode contains excess of electrons. So the rod acts as a negative charge. This electrolyte solution having positive charge. There is a development of the electric double layer. This negative charge and this positive charge. Therefore, the electrode potential is the difference between the metal rod and its electrolyte solution. What is the electrode potential? It is the difference between the potential between metal rod and electrolyte solution. Factors effects on single electrode potential. What are the factors affects the single electrode potential? Nature of metal rod and the concentration of ions in the solution, temperature. Nature of the metal rod, the concentration of ions in solution and temperature. These are the factors affects the single electrode potential. What is standard electrode potential? What is standard electrode potential? The electrode potential measured at standard conditions. The electrode potential measured at standard condition called standard electrode potential. What are those standard conditions? 1 molar concentration of electrolyte solution and 298 Kelvin temperature. 298 Kelvin temperature also we can call as 25 degrees centigrade. In degree centigrade we call 25 degrees centigrade. And 1 atmosphere pressure. These are the standard condition. In the standard condition, if you measure the potential of the electrode, that potential of electrode is called standard electrode potential. Measurement of single electrode potential. How we can measure the single electrode potential? We are not able to measure the single electrode potential of an isolated half cell. for isolated half cell, we can't measure the single electrode potential. But we can only measure the electrode potential difference between when two half cells are connected. We can measure the potential difference between when two half cells are connected. Then we can calculate potential difference. In order to measure single electrode potential, it is necessary to couple an electrode with reference or standard electrode. In order to measure the single electrode potential, that single electrode potential should be connected to either reference electrode or standard electrode. The reference electrode or standard electrode values are fixed; they will not be changed. Then we can calculate the difference between this single electrode and this reference electrode. Then we will get the electrode potential of that single electrode. What is electromotive force or cell potential? The potential difference between two electrodes of galvanic cell is called the cell potential. It is measured in volts. What is electromotive force or cell potential? The potential difference between of two electrodes of galvanic cell is called cell potential. What is the galvanic cell? In last class I have explained what is galvanic cell. Galvanic cell consists of two half cells. One is anode half cell, one is cathode half cell. At anode, oxidation takes place. At cathode, reduction takes place. This anode contains some electrode potential. Similarly, cathode exhibits some electrode potential. Both are not same. Then the difference between these two electrodes called electromotive force or cell potential. The potential difference between these two electrodes is called electromotive force or cell potential. The EMF of the cell depends upon temperature, nature of reactant, and concentration of solution in two half cells. The EMF depends upon temperature, nature of reactant, and concentration of solution in two half cells. How we can calculate the EMF mathematically or cell potential mathematically? EMF or E cell equal to reduction potential of cathode minus reduction potential of anode. Reduction potential of cathode minus reduction potential of anode gives the cell potential or EMF. Or E cell equal to E right minus E left. What is meant by E right? E right means reduction potential of right hand side electrode. Right hand side electrode in galvanic cell, right hand side electrode is cathode. That means the reduction potential of cathode minus E left. Reduction potential of left hand side electrode means left hand side electrode is anode. The reduction potential of left hand side are anode. The reduction potential of an electrode is an equally in magnitude but opposite in sign to its oxidation potential. If any electrode, let's say copper electrode, if I say copper electrode oxidation potential is minus 1.12 volts, then its reduction potential becomes plus 1.12 volts. The oxidation potential, if I take minus 1.12, the reduction potential of that electrode becomes plus 1.12. The magnitude will not change, but the signs will be changed. Reduction potential of electrode equal to minus oxidation potential of that electrode. Some numerical problems on EMF calculation. Example 1. For a reaction, 2Ag plus Cd gives 2Ag plus Cd plus 2. And the standard reduction potential given are for silver 0.80 volts and cadmium minus 0.04 volts. Then calculate the cell potential. Before going to this problem, this cell equation we are converting into electrochemical cell representation. In electrochemical cell representation, salt bridge I am writing. Okay. Left side anode reactions and right side cathode reaction we have to write. At anode what happens? At anode oxidation takes place. At cathode reduction takes place. At anode oxidation, at cathode reduction takes place. In this reaction, which one undergo oxidation? I have to check. Cadmium forms cadmium plus 2. So, cadmium undergoes oxidation. Then anodic reaction becomes cadmium into cadmium plus 2. Here, which one undergo reduction? Silver plus convert into silver. Then silver and silver cation undergo reduction. So, cationic reaction is Ag plus and Ag. This is the reduction at cathode. Okay, this is oxidation potential. This is the oxidation reaction. This is the cathodic reaction. Then we given Ag plus to Ag 0.80 volts. Here Ag means E cathode. E naught of cathode is 0.80 volts. Cadmium is anode. So E naught anode equal to minus 0.40. We know the cell potential equal to E naught of cathode minus E naught of anode. E naught of cathode equal to 0.80 volts minus E naught of anode equal to minus 0.40. Substitute these values in this equation. Then we will get 0.80 minus of minus 0.40. Minus into minus becomes plus. Then 0.80 plus 0.40. The final answer is 1.20 volts. The cell potential of this reaction is 1.20 volts. Example 2. Calculate the EMF of voltaic cell Fe plus 2, salt bridge, copper plus 2. In this, we have to find EMF of the cell. The copper electrode potential given and iron electrode potential are given. First, we have to find out anodic reaction and cathodic reaction. At anode, this is salt bridge. This is left side is anode. Right side is cathode. So, E naught of anode nothing but E of Fe into Fe slash Fe plus 2. So, it is given minus 0.44 volts. What is cathode? Here cathode is copper. E cathode equal to E Cu plus 2 Cu equal to plus 0.34 volts. From cell potential equation, E cell equal to E cathode minus E anode. What is cathode here? Cathode is copper potential. So 0.34 volts minus E anode nothing but minus 0.44 volts. Substitute this equation. 0.34 volts minus into minus plus 0.4 volts and final answer is 0.78 volts. Electrochemical series. What is electrochemical series? The electrode potential of different electrodes can be finding using standard hydrogen electrode. By using standard hydrogen electrode, unknown electrode potential can be calculated. The potential of hydrogen electrode as assumed as 0 volts. By using reference electrode hydrogen potential by using standard reference electrode hydrogen electrode we can calculate the unknown cell potentials of electrodes by taking the standard hydrogen electrode potential as 0. The arrangement of different standard electrode potentials of different electrodes from highest negative to highest positive are called electrochemical series. The arrangement of the standard electrode potential in different electrodes from highest negative to highest positive. On top highest negative, on bottom highest positive. This arrangement is called electrochemical series. See, in this electrochemical cell, this is the electrochemical series. In this, the highest negative reduction potential minus 3.04 volts lithium electrode, it is in top, and similarly this values will decrease and reaches 0 and the positive values increases. Plus 2.8, this is the highest positive standard reduction potential value. The applications of electrochemical series. Predicting the feasibility of cell reaction. By using electrochemical series, we can know the feasibility of the reaction, whether reaction is possible or not. The feasibility of redox reactions can be predicted with the help of electrochemical series. The feasibility of redox reactions can be predicted with the help of electrochemical series. Already we know inert cell potential we can calculate by using this formula. Inert cell equal to inert cathode minus inert anode. Okay. In general, if inert cell is positive, the reaction is feasible. How we can say if inert cell is positive, the cell reaction is feasible? There is a one thermodynamic equation. Delta G equal to minus N F E cell. Delta G not equal to minus N F E not cell. This is the change in standard Gibbs free energy. This is the change in Gibbs free energy. N nothing but number of electrons involved in the cell reaction. F is Faraday constant. Faraday constant, this value is 96,500. And inert cell, this is the cell potential. N and F are constant. Then delta G depends upon inert of cell. Okay. If E cell positive, what happens? E cell is positive, then delta G not equal to minus inert cell positive means inert cell plus minus into plus minus. So delta G not equal to minus or delta G not becomes negative. So if Gibbs free energy becomes negative, the reaction is spontaneous. The reaction is spontaneous and feasible. So if inert cell is positive, the reaction is feasible and spontaneous. If inert cell is negative, what happens? Delta G naught becomes positive. So the reaction becomes non-spontaneous and not feasible. If inert cell is negative, the reaction is not feasible and non-spontaneous. Example 1. Predict whether reaction is feasible or not. Predict whether the reaction is possible or not. The reaction between silver and zinc is feasible or not, you have to check. Given the E anode given 0.80 volts and E cathode given minus 0.763 volts. We have to calculate the cell potential by using these values. Inert cell equal to inert cathode minus inert anode. Inert cathode nothing but minus 0.763 volts. Substitute here minus, instead of minus I kept minus here, and inert of anode equal to 0.80 volts. Then minus into minus becomes minus, and the total value becomes minus 1.563 volts. Since E cell is negative, the given reaction is not feasible. Since E cell is negative, then delta G becomes positive. Hence, the given reaction is not possible, not feasible. Example 2. Predict whether the reaction is feasible or not. The reaction between aluminum and tin the reaction is feasible or not. He has given E naught anode minus 1.66 volts and E naught cathode plus 0.15 volts. We have to calculate the cell potential of this reaction. Then E naught cell equal to E naught cathode minus E naught anode. E naught cathode is equal to 0.15 volts minus E naught of anode equal to minus 1.66 volts. Then E naught cell equal to 0.15 volts minus of 1.66 volts. Then total cell potential becomes 1.81 V volts. Since E naught cell is positive, hence the given reaction is feasible. If E naught cell is positive, then delta G becomes negative. Then the reaction is feasible. Second application of electrochemical series, reactivity of metals. Metals are reactive if they lose electrons easily or their tendency to form cations. If metal lose the electrons, then they form cations. Then the cations are very reactive. Those metals with a high negative value of smaller positive value of standard reduction potential lose electrons quickly and are highly reactive. The electrodes which are having highest negative values of standard electrode potential are less positive of standard electrode potential undergoes oxidation and forms cations. The group 1 and group 2 metals have high negative reduction potentials and therefore they are easily dissolving acids. Group 1 and group 2 metals have high negative reduction potentials, undergo oxidation very easily. So they are very soluble in acids. The third application of electrochemical series is oxidizing and reducing strength. The electrochemical series helps to identify different materials that are good reducing and oxidizing agents. By electrochemical series, we can identify which is the strongest oxidizing agents and which are the strongest reducing agents. All substances that appear on top of the electrochemical series acts as good reducing agents. At the top of the electrochemical series are having highest negative reduction potentials are good reducing agents. Nothing but they undergo oxidation very easily. All such substances that appear at the bottom of the electrochemical series acts as good oxidizing agents. Bottom of the electrochemical series are having highest positive standard reduction potentials. They are good oxidizing agents. Means they undergo reduction very easily. In electrochemical series, top of the electrodes undergo oxidation very easily because they are having highest negative standard reduction potential values. At the bottom of the electrochemical series, they are having highest positive standard reduction potential values, so they are undergo reduction very easily. Example, in galvanic cell, zinc and copper electrodes are connected in electrochemical cell. In galvanic cell, zinc and copper are connected. But in that case, zinc acts as anode, copper acts as cathode. Why? Zinc standard reduction potential is minus 0.76 volts. But copper standard reduction potential is plus 0.15 volts. This is the highest negative standard reduction potential, zinc. So, it's undergo oxidation. Similarly, copper is plus 0.15 volts. If compare this to this is having highest negative standard reduction potential. It is highest positive standard reduction potential. So, zinc undergo oxidation, copper undergo reduction. The problem on this. Calculate the EMF of cell if the reduction potential of the cell are minus 0.763 volts and 0.337 volts. In the last two problems, they given some reactions, anodic reactions and cathodic reactions and their potentials. Then we have identified which one is anode, which one is cathode. But in this, they didn't mention any reaction, but they mentioned standard reaction potential values. By this, we have to find out which one is anode, which one acts as cathode. See, it is standard negative values. This is highest negative standard reaction potential value. This is highest positive standard reaction potential value. You compare these two, the highest standard reaction potential value acts as anode because it undergo oxidation very easily. So, E naught of anode equal to minus 0.763 volts. Similarly, E naught of cathode equal to, this is highest standard reaction potential, so it acts as a cathode. E naught cathode equal to 0.337 volts. So, E cell equal to E naught cathode minus E naught anode. So, E naught cathode equal to 0.337 volts minus, instead of minus I kept minus, E naught of anode equal to minus 0.763 volts. Substitute these values in this equation, then we will get the final answer is 1.1 volts. By this, we can find out which one is anode, which one is cathode by electrochemical series. The displacement reaction. The substance with a lower standard reduction potential. The substance with a lower standard of reduction potential will displace the metal from the salt solution with greater value. The lower standard reduction potential metal displace the highest standard reaction potential metal in the salt solution. Example, copper reaction with silver nitrate. Copper displaces the silver and forms copper nitrate. Why? The copper standard reaction potential electrode is plus 0.15 volts. The silver standard reaction potential is 0.7 volts. If you compare these two, copper standard reaction electrode potential is less compared with the silver standard reaction potential. Hence, this copper replaces the silver metal. The fifth application of electrochemical series is prediction of metals' ability to liberate hydrogen gas from acid. All metals with negative electrode potential have increased tendency to lose electrodes compared to hydrogen. If negative electrode potential be put in HCl, what happens? We'll see. If I take HCl, dilute HCl, any negative standard reaction potential electrode, let's say sodium or lithium, first group 1 and group 2 are having highest negative standard reaction potential. So I am taking sodium. These electrode potential is in negative, but we know the H plus hydrogen standard reaction potential value is 0. If you compare the standard reaction potential of hydrogen and this electrode, these are having negative charge, negative standard reaction potential. Hence, these undergo oxidation. The sodium metal undergo oxidation. At the same time, the hydrogen plus undergo reduction due to the standard reaction potential value is 0. So it undergo oxidation. H plus undergo reduction and forms hydrogen gas. Hence, when such a substance is placed in acid solution, it gets oxidized and an effective reduction of H plus ions occur to form hydrogen gas. H plus ions undergo reduction when we dip the negative standard reaction potential electrode in the acid. Therefore, substances having negative E values have the potential to free the hydrogen from different acids. In sodium metal dipped in HCl, it forms NaCl and it's evolved the hydrogen gas. Predicting the product of electrolysis. What is meant by electrolysis? In last class I have explained. Electrolysis is nothing but electrolytic cell reactions. Electrolytic cell reactions are called electrolysis. Electrolytic cell I have explained electrolytic cell reactions. In beaker, I have taken molten NaCl and two inert rods are dipped. One acts as anode, one acts as cathode. These two electrodes are connected to external battery source. The positive terminal connected to anode and negative terminal to cathode. What happens here? The NaCl electrode, molten NaCl contain Na plus and Cl minus. The positive charge developed here. This Cl minus ion migrates towards this anode. The Na plus ions migrated towards the cathode. At anode, Cl minus undergo oxidation and at cathode, Na plus undergo reduction. If two ions only there, so one is undergo oxidation and other one is undergo reduction. But if I take, instead of molten NaCl, if I take aqueous NaCl, I have taken aqueous NaCl instead of molten NaCl. In this aqueous NaCl, water also forms ions like H plus and OH minus ions. NaCl undergo forms ions and Na plus and Cl minus ions it will form. So here there are 4 ions. 2 are cations, 2 are anions. In this, which one will undergo oxidation and which one will undergo reduction first? In these 2 cations, which will undergo reduction first? In these 2 anions, which one will undergo reduction first? So, if in the case of cations, the cations which are having highest positive electrode standard reaction potential, that will undergo reduction first. In cations, which one are having highest standard reaction potential values undergo reduction first. In case of anions, the least standard reaction potential or highest negative standard reaction potential which are having that undergo oxidation first. In case of two or more types of ions are present in the electrolytic solution, they are liberated at the electrode according to their preference during electrolysis. The cations with high value of standard reduction potential are discharged first. In these two cations, which are having highest standard reduction potential value, that undergo reduction first. Similarly, in the anion with low standard reduction potential value, liberated first. In case of anions which are having lowest standard reduction potential value, that undergo oxidation first. When an aqueous solution of NaCl containing Na plus, Cl minus, H plus, OH minus ions is electrolyzed, the H plus ions preferably deposited at the cathode. The H plus ions undergo reduction first compared with Na plus. Why? We'll see. This is because the reduction potential of hydrogen is 0. Already we know the reduction potential of H plus is 0. And the reduction potential of sodium is minus 2.71. If you compare these two standard reduction potential values, the hydrogen contain highest standard reduction potential value. So it's undergo reduction first. In compare with H plus and Na plus, the hydrogen undergo reduction first. At the same time, at the anode where the oxidation takes place, the anion that has lower reduction potential will oxidize. If we compare the anions, which one having lowest standard reduction potential value, that undergo oxidation first. Therefore, OH minus with standard reduction potential is 0.40 volts. Similarly, Cl minus having 1.36 volts. If compare these two, the OH minus ions contain less standard reduction potential value 0.40 volts. Hence, it undergo oxidation first. By this, we can predict the which one in electrolysis, which one undergo oxidation and which one undergo reduction. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.